Hey everybody, so we are looking at this problem k closest points to origin. We are given an array of points. What does it mean by point? Points I is xi and yi. These are points in a coordinate, an xy plane. We are supposed to find out k closest points from the origin, and that would be 0, 0. We are given the formula for Euclidean distance. I think we all know about this formula from the math class. We can return the answer, which means the k closest points to the origin. We can return those points in any order. Also, there is no repetition of distance, so we should not be confused, which point to return. So we are guaranteed to have unique distances. Let's take a look at this example. Points equals to this and this. From the diagram, we can say that, okay, this is the distance and this is the distance. Visually, we can say this one is a closer point, which is -2 and 2. And yeah, this is the closer point. We are supposed to find out k equals to 1. So just one point we are supposed to return. If k was equals to 2, we would return both the points. A very naive approach to solving this problem would be, let's calculate all the distances, put them in a list, and let's sort the list. So over here, that would be under root 10 for the first point, and under root 8 for the second point. And we can sort this out. So under root 8 and under root 10, and k equals to 1, which means just this element. Now over here, we are using n log n time. Can we do it better? Yes, we can. So a better solution to this problem would be, let's make this observation. We just need k closest points. If we have already some number of points over here, there is no point of keeping and sorting any number of points after that. If we have the k closest, there may be more points coming in. But if we have an array of 100 elements and we know we just want 2, so how about we maintain a list of just the 2 smallest elements we have found so far? In that way, we don't have to sort the entire array, and we save our time with this over here. We don't have to sort everything. So we can find an n log k algorithm where we just sort k elements. So how do we do that? We can use a data structure, which is a max heap. And how can we use it? Well, let's just take this example. Let's say I have a max heap. I come over here, I find the distance and what that would be under root 10. I put that in a max heap. Next up, I have under root 8 as my distance. It's a max heap. Under root 8 is inserted. We need k equals to 1. So over here, we would be like, okay, under root 10 is over here, under root 8 is over here, k is equals to 1. We don't need one of the element. And that element we know is under root 10, which is at top of a heap. We can delete the top of a heap, which means we are left with under root 8. That's it. So if we had more elements, something like this big, and we were like, okay, we just want 3 elements. In that case, we have 5 elements over here. Since we need the closest, we would remove the top element, which means we remove the largest. It's a max heap. We remove the largest, and now we are end up with something like this, but we still have one extra element. This element over here would be a very large number, so we can remove it, and we are at this position. So we can say that we have 3 elements in this heap and they are the smallest of all. In this way, we can save ourselves from sorting unnecessary elements. We can just keep k elements. Now let's take a look at the code implementation of this problem. So I'm here in the code editor. I have this function given k closest. It has points, which is a list of list, and we are given the value k. And we need to return k smallest points. So first, I would like to create a heap in Python. This is how you can do it. It's basically a list. Next, I want to iterate through all the points. So for x comma y in points, I have the xy coordinates. I want to calculate the distance. So x square 2 plus y square 2. I'm not taking under root because I just need a relationship between the distances, not the actual distance. Next, I want to insert this distance inside the heap along with the coordinates. So I can do that in Python using heap q, heap push. Then I need a heap and what I need to insert. And that would be negative of distance and x, y negative, because in Python you only have a min heap, not a max heap. So how you go around it in Python is that you take the negative of the distance and that acts as a max heap. So next up, I would like to check if the number of elements in this heap are more than k. If they are more than k, I would pop the top element. So if the length of this heap is more than k, I would like to pop the top element. So heap q dot heap pop, and I need to pass the heap. So now I can for in this for loop, I can go across all the points, calculate their distances, put them inside heap. If it's more than k, just pop them out. So now I'm left with just k elements inside the heap. So let's return all those k elements. So what we can do, we can return that using a comprehension point for underscore comma point in heap. So how it works is um, this is basically a for loop. So you have this element taken out of the heap. The first element is distance. We don't care for that. And then next is point, and that point is returned over here. So this will give us a list of all the points. Let's run this code. Let's submit it. So we have a solution.